Okay, hi everyone. Can you hear me? Great. So I'm really excited to be here today talking about GraphQL. It's a technology that I really believe in. I think the Clojure community, I'm going to try to do a better job of holding this steady. Just start waving if I waffle around. Okay. It's a technology that I really believe in and I think the Clojure community could do very well with. This is a somewhat provocatively titled talk that I gave at Clojure D in Berlin, basically just trying to convince more Clojurists to adopt GraphQL. And for that reason, I was really thrilled to see that Workframe was hosting this meetup specifically about GraphQL. So big thank you to Andy and Workframe for inviting me to speak here and for hosting this. So a little about me. My name is Dom. I'm a partner at a small Clojure consultancy called Paren. We generally work with startups and do React and React Native stuff. I used to live in San Francisco and actually just moved to New York City. So I'm very excited to be here and to meet all of you and come and talk to me. Maybe we can hang out. So today we're going to be talking about GraphQL. But before we do, obviously we need to talk about Japan. So I spent some time in Tokyo in January. This is a picture I took from the 45th floor of the Tokyo Metropolitan Government Building. Tokyo is an incredibly huge city. It's literally a city as far as the eye can see. And everywhere I went in this huge city, and every bathroom I went into, I found one of these. This is an electric toilet, and they are ubiquitous in Japan, and they're awesome. They have heated seats, they clean themselves, they clean you. They're incredible and they're everywhere. And I realized walking around Tokyo that using GraphQL is a little bit like using Japanese toilets. It's awesome, it's convenient, it's way better than the alternative, but it's still kind of shitty. So, today, we're going to be talking about GraphQL, and yes, we are also going to be talking about electric toilets. But before we do, let's talk about some misconceptions about GraphQL. These are all things that I've heard specifically in the Clojure community. Atomic is better. It's been doing what GraphQL has been doing since 2013. Like, well, why do you need GraphQL? Or just use SQL. It's been around forever. It's way more flexible. You can have a real query language. Or I don't need a graph database. I'm fine with Postgres. It works great. These don't make sense. GraphQL is an API layer. It has nothing to do with the storage layer. It's poorly named, in my opinion. Facebook does have a graph concept built on top of it in Relay that uses nodes and edges, but that's not part of GraphQL, and you don't need a graph database, and you can use any database or no database. It's just an API layer. So, today we're going to be talking about GraphQL, and we're going to be talking about REST. They're similar, in purpose, a little different in use. They both get the job done, sort of. And you might use them to solve some of the same problems, but I would hope you'd use them a little bit differently. And I think you'll be a lot happier with the former, at least I will. So, in an application, GraphQL is the API layer. Like REST, but unlike REST, GraphQL has a specification. So GraphQL describes behavior, it does not describe implementation. There are GraphQL server implementations in every mainstream language, including Clojure. So GraphQL defines is a spec, and that spec defines a type system, a formal language for defining a schema, a formal language for operations like query, mutation, subscription, rules for validating those operations, and rules for executing those operations. And that is all GraphQL is, okay? GraphQL is not perfect. I have a lot of complaints about it, and I will share some of them here today. This is not intended to be a hype talk. Speaking of complaints, I actually have a complaint about hype talks, or tech talks in general, which tend to be hype talks. I actually made a graph about it. So I tend to go, and I'm missing an emoji there on this computer, interesting. I think that one was like some crying thing. Anyway, so I tend to go, have some problem, and I start out, it works. It's not good. It could use some improvement. So I watch them talk, I try to figure out improvements for it, and I find something, and it's going to solve everything. Seriously, it's going to solve everything. And then I start to use it, and it solves nothing. Like, this is way overpromised. And then if you get, into it, and then, figure out the limitations, it actually turns out to be pretty useful. But not what was promised. So the goal of this is to get you to, actually, GraphQL looks quite useful at the end of the talk, and get past the hype. Most of this talk is about the UI. We're going to be talking about ClojureScript and UI stuff. But before we do, we need to talk about the server. So a server defines a schema, and that defines the functionality of the API. So this is a schema definition that uses GraphQL's schema definition language. It's part of the spec as of very recently. So this is a schema that has brands and it has models. They both have names and they have references to each other. And you will also notice that this says type. And yes, they are types, regardless of how you feel about types in programming languages. I hope that we can all agree that types or specs or validations or whatever you want to call them are very useful at system boundaries. And that's what GraphQL is. It's your API. It's a very important system boundary. The type system is also extensible. It's like EDN or transit. If you want to add a datetime type, no problem. You can do that. It's also introspectable, which means you can query the API to programmatically understand the capabilities of the API, which is incredibly useful for tooling, which we'll take a look at a bit later. So after that, you would have a client, and that would define a query. So here's a query. So a query is basically like a map or a tree, but only has a few keys. So there's no values in it. So this might be a query that a client could define. So saying, get me all the brands, just their names, and get me all the models, just their names. The server will then send back a response in the same format. So in here, you can see that it's basically the same thing, except that there are values as well as the keys. So in here, we're saying there's one brand, that's Toto, which is the largest Japanese, at least, toilet manufacturer. And then we have one product, which is the Neorest 600, which actually costs over $5,000, and I want one, but it's a different issue. So the last part that you may be wondering about is that, so we have this schema, we have these queries. How do we actually return data? That's what resolvers are for. So resolvers are just functions. They can contain arbitrary code. They can talk to other GraphQL servers if you want. They can do whatever you want. They're just arbitrary code, arbitrary functions that allow you to intermediate. It's very useful to have an explicit API layer that decouples your API schema from your storage schema. It allows you to draw data from multiple sources or change your backend schema without affecting your API, or add like aggregate or complex fields to your API very easily, without affecting clients. Okay, so that's all I'm going to say about the server side. Let's get back to the UI. Okay, so a GraphQL client does not have to be UI or doesn't have to use React. It can be another server, it can be whatever. But today we're just going to talk about UI. To fully benefit from using GraphQL when building UIs, you really, I think, need a good client library. So primarily today, your options are Relay, which is created by Facebook and runs with React and React Native, or Apollo, which is created by Meteor and works with React, Angular, iOS, Android, and a bunch of other things. Most of the examples today we're going to look at are Apollo and React. React because probably everyone's familiar with it. And GraphQL really works with any declarative UI, or works well with any type of declarative UI like React. And Apollo because it's frankly a lot easier to use from ClojureScript than Relay is. So first let's talk about co-location. You don't put the toilet paper in another room or very far away. You try to remember to bring it with you, right? You co-locate it with the toilet, it's convenient. You co-locate toilets and toilet paper for the same reason, because you need the latter to use the former, right? So with REST, there's no easy way to declaratively state your data requirements and collocate these declarations with your UI components. But that's quite easy with GraphQL. Okay, pardon the JavaScript, but I can assume that everyone can read this because that's the world we live in, unfortunately. There isn't an open source Apollo 2 ClojureScript wrapper. Using ClojureScript interop here would make it even more verbose, so I'm just sticking to JavaScript. The one part of this that you might not recognize is the GraphQL backtick thing. That's a ES6 template literal. It's just a string. It's just a string that it supports interpolation. And it has syntax highlighting here, but it's just a string. So you can see here that we have a GraphQL query. It's collocated with a React component. This is super useful because you don't need to look elsewhere to figure out where your data comes from. Now, on to the negative things. So as I said, this query is just a string. And knowing that you're embedding raw strings of GraphQL in your code might fill you with some amount of frustration. It certainly annoys me, especially because there doesn't seem to be a good way to provide syntax highlighting for the stuff in Emacs closure mode, at least, yet. And if you're like me, you're probably looking at this and thinking, how can I turn this into maps and vectors and sets? I want data, right? There is a closure library for this. If you absolutely find strings intolerable. However, I would caution everyone to really try to stick with strings. Raw strings are very useful for multiple reasons. In a similar way to what the closure community has realized with SQL using Hug SQL, right? So raw strings support the full GraphQL spec, not a subset from some DSL that compiles GraphQL. Raw strings don't need to be relearned by other people who already know GraphQL. They can be copied directly into GraphQL tools, which we'll see a bit later, and is incredibly useful for development. And there are some tools that operate on code bases, and will scan them for GraphQL strings and then validate or compile those strings. So if you don't have them there and you have some DSL, you can't use those tools. In terms of other GraphQL features, I found this absolutely delightful video from Toto, that Japanese toilet manufacturer that I mentioned. So we're going to watch it.
Take the toilet lids, for example. They open automatically when you approach the toilet. This mimics the Japanese taxi that automatically opens its doors for passengers, or the way employees of an establishment line up to greet customers with a deep bow.
Okay. So, it senses what you want, and it opens for you. With a normal toilet, your actions and your assumptions about the state of the toilet, aka the toilet seat position, can differ. The seat can be up when you think it's down, it can be down when you think it's up, it's a mess, right? It's up. This is the case with REST, right? You have resources A, B, C, they have references to each other, you want to render something, it relies on the data of these different things and those references. You might have to download that in multiple chunks, connect it, deal with network failures, server failures, etc. You have potentially dozens of partial loading states and possible failure states as well. It's frankly a mess, and it's pretty difficult to deal with. So, like an electric toilet will always open the lid when you need it, GraphQL will always load the data before you use it. So with GraphQL, the seat is never half open or in an unexpected state. You don't have partial loading. This is taken care of by the library, in this case Apollo. You either have the data, are loading the data, or you have an error. So in this example, you can see we're rendering a component, and we're dealing with all the possible states in a single place. So is it loading? Render a loading div. Did it error? Render an error div. Did load successfully? Load the main content. Now, you might be too excited about how awesome this will make your life, building UIs. So I'm going to be a buzzkill real quick. Let's talk about errors. With a normal toilet, when it's broken, it's relatively easy to diagnose and fix. With one of these electric toilets, when they malfunction, I would think it would be a lot more difficult to fix. Similarly, all those nice things that I said about the GraphQL type system do not apply to GraphQL errors. GraphQL specifies that you may return errors, and that each error is represented as a map, and that those maps need to have a message key. But that's basically it. The rest of it is mostly undefined and untyped. This is a completely valid GraphQL response. The errors, however, do not convey meaning within the type system at all. So we have a server error, we have a validation error, but without out-of-band communication between the server team and the client, the UI team, they're meaningless, right? So you still have to do that communication. With REST, responses are basically all or nothing, right? So you have a request and it either succeeds or it fails, and then you have a status for that whole request. But that's not how GraphQL works. So requests can be partially successful, and because of that, GraphQL servers typically don't use status codes the same way that REST servers would. They'll just return 200 for everything because the status is not meaningful when you have partial failures, and that's an acceptable thing. But what this means is that common error types that you know, like auth errors, server errors, validation errors, etc., those are left entirely as an exercise for the developer. And that means that the tools that we'll discuss later on, which are overall awesome, don't deal with errors because they're, again, barely part of the GraphQL spec. Like, this is very unfortunate. It puts a substantial burden, I think, on developers to reinvent standards when they're dealing with errors in every single web application they use GraphQL. So this is a part of the spec that I hope will be improved in the future. Anyway, let's get back to our video.
When the lid opens, don't be afraid. Go ahead and have a seat. You may be surprised that the seat is warm. You might think a sumo wrestler was sitting on it, but the heat is actually generated by the built-in heater that warms the seat to an approximate body temperature.
Okay, so a normal toilet starts out uncomfortable, and you have to make it comfortable. This one starts out comfortable. It requires, very little effort from the user. Now, if you use REST to build your UI, you have to write your own abstractions, right? You have to make assumptions about your API or APIs. There's a lot of work to be done, and it's very error-prone. So like an electric toilet starts out comfortable and saves you the effort of making it comfortable, GraphQL starts out easy and saves you the effort of writing your own API wrapper. This is a valid Apollo configuration. It will completely handle your network layer, your queries, your mutations, your subscriptions with a very, very basic configuration. In reality, you're going to have something a bit more complicated because you'll probably add some auth headers in there and stuff like that. But this is the gist of it. It's very easy to set up and get going.
There is another function that you may find charming. Japanese women tend to become embarrassed when they are heard using the toilet. To be discreet, women would flush the toilet once to mask the noise, and then a second time to flush when finished. That is how otohime came to be developed. The sound of a toilet flushing is emitted from a built-in speaker, so you only have to flush the toilet once.
Okay, well, that's quite sexist. I would totally use that feature. I think many of them would, but anyway, it's a nice feature. It saves you embarrassment. It saves the environment by saving water. Anyway, so GraphQL, due to collocation and all or nothing loading, makes it much easier to write error-resistant code, leading to less embarrassing production bugs. What I find really embarrassing when I'm using the internet are UI components that get out of sync with each other, which I find all the time. So let's say you have components A and B, and they care about intersecting sets of data as represented by these queries. They both care about the name of this user. How do you keep them in sync? With REST, you maybe use something like Reframe, and you keep both of them in sync by keying them by their primary ID in some global app state, right? That works, it definitely works, but it's tedious and it's error-prone, and it's especially error-prone when you're dealing with resources that reference other resources, right? So a GraphQL client, on the other hand, can automatically normalize your data and bind it to components for you. So components A and B that care about these queries are guaranteed to show synchronized data. So if the data changes, both A and B will render simultaneously and show the correct data. We also care about the environment, and that's the reason why we have this flushing sound feature, right? So we don't want to waste water. And similarly, we don't want to waste data. So GraphQL can help you save data by using persistent queries. Persistent queries are queries that you upload at build time, and at runtime, the client will only send a query ID and variables instead of the whole thing, which vastly minimizes loading time. So as an example, if you at runtime are sending this query, you're probably going to be sending this JSON, right? And it's running off the screen because it's some big thing, and in production it can be, huge, right? What you can do is at build time, you can upload this to a server and get an ID back, and then at runtime, instead of sending the actual query, just an ID that references that query. This is a dramatic improvement for load time.
A whole set of buttons may make you wonder if you are in a cockpit. Each button is there to take you to a journey of safely and comfortably cleaning your beer.
I can show you that, if anything, the real experience is much more thrilling in this video. Okay, anyway, so the toilet, it has a remote. You request something, you get something. You don't get extra things that you didn't request. You don't not get the things you requested, right? You get exactly what you request. With REST, you have no control over that experience. But with GraphQL, you request and you get exactly what you want, just like an electric toilet. No more, no less. So in this query that we used before, it gets the names of the brands and the names and models of those brands, right? It doesn't get anything else. You need to explicitly request other things if you want other things. So like persistent queries dramatically improve upload performance, fetching only requested fields dramatically improves download performance, right? So you get that on both sides of it. You can also combine queries using fragments or batched requests, and that allows you to load your UI using very few requests or even one request to get all the data that you need.
When you press the rear button, warm water will spray from a nozzle. The water sprayed from the nozzle is angled at 43 degrees, the optimal angle found after extensive research. There are also buttons like soft and pulsate for you to adjust the spray to your liking. From the first press of the buttons, you'll experience and enjoy Japanese innovation and hospitality.
Okay, well, what more is there to say, Bill? I am pretty curious about their extensive research. Okay, so obviously this solves a problem. There's less manual cleanup necessary. So using REST, you're forced to clean up your own data and your own components. Like an electric toilet cleans up for you, so do GraphQL clients, right? So for example, let's take a look at optimistic mutations. So an optimistic mutation is where you simulate instant successful mutation to give the perception of a more performant UI. This is actually a pretty difficult thing to do with REST, at least in a generic way, because you need your own system for reconciling, updating, and binding data, and you need to use that system consistently and pervasively throughout your entire application. You'd also need a way of replacing optimistic data with real data and cleaning up watchers of this data when they unmount or otherwise change their data requirements. With GraphQL, it's pretty easy. When you mutate data, you can supply an optimistic response that the client will pretend is the real data and update all components that need that data. Once the real response comes back over the network, the GraphQL client will update the store and cause all watching components to re-render. If the real data is different from the optimistic data, they'll re-render, and if it's the same, then they won't, right? So you don't need to clean up anything, the client does it for you. So just as React lets you offload UI rendering and cleanup, GraphQL lets you offload data management and cleanup. You can push this complex, error-prone, application-specific logic into an open-source, uniform, maintained library. So when your component unmounts, your GraphQL client will clean up subscriptions and queries that were being watched. You don't need to think about it. You don't need to get your hands dirty. And then you might be asking, why not just use Reframe? Reframe, it doesn't do optimistic mutations, but it can certainly help with automating cleanup. And Reframe and Redux are fine. But locking is also a fine way of dealing with concurrency and mutable data structures. It's a reasonable approach to dealing with an extremely difficult problem. And that's what Reframe is. It's a very reasonable approach to dealing with extremely difficult problems caused by REST. So GraphQL is to REST as immutable data structures are to mutable data structures. GraphQL is not a treatment, it's a cure. And you might be thinking, Reframe is so much more than remote data management. But I would challenge you to think about that a bit further. In my experience, the vast majority of reframe code has to do with either like fetching remote data or updating remote data or updating local data that's derived from that remote data or synchronizing different components with that data, right? Like it's not all related to remote data, but most of it is. And with that said though, like, nothing prevents you from using GraphQL in conjunction with reframe. Like that's a perfectly reasonable thing to do, especially if your app has a lot of local data or if you're already using reframe and want to migrate over to GraphQL. However, there is a relatively new part of Apollo 2 and Relay Modern that allows you to use GraphQL for local data as well as remote data. It's called schema stitching. Quick negative about this, GraphQL doesn't support namespaces, which makes this a little annoying because if you're merging multiple schemas, then you have to be aware that you don't have any overlaps between them, right? But otherwise, this is pretty awesome. So this is an example query that we might have if we were using schema stitching. So this will allow a client to retrieve the, this would allow a component to, in a single request, get the user's name, which is stored on the server, get the user's device-specific settings, which are stored locally in something persistent, maybe local storage, right? And the application in-memory state, right? So all of that result in a single query at the same time with errors, combined and everything. This is really awesome. And this means that you can use Apollo or Relay to fully replace Redux or Reframe. Like you can deal with local data as well as remote data. It's relatively new and I'm pretty excited about it. So, why not use something ClojureScript specific? Could you design a toilet that worked better for their specific use cases? With enough effort, I think you probably could. But should you? The plumber won't know what to do with it, the building pipe's probably right. So the big reason to use GraphQL at this point is, I think, the ecosystem. GraphQL was initially released in 2015, but the ecosystem is already vast and it's growing rapidly. So if there's one reason to use GraphQL instead of something ClojureScript specific or something ad hoc, it's the ecosystem. The following languages have one or more GraphQL server or client libraries. Clojure, hooray. Elixir, Elm, Erlang, Go, Haskell, Java, JavaScript, Julia, Kotlin, Lua, .NET, OCaml, Perl, PHP, Python, R, Ruby, Rust, Scala, Swift. Swift, yeah, Swift. Side note, every other SVG converted to pin correctly except for PHP. It just seemed appropriate to leave it totally broken. So moving on. Let's say you want to learn more about GraphQL. You have How to GraphQL. This has tutorials for front-end, back-end, tons of different clients and languages, tutorials and everything. Let's say you want an extremely performant React-specific client. You have Relay. Let's say you want a still performant enough, probably client that works in Vue, React, Angular, Android, iOS, Ember, Meteor. You have Apollo client. Let's say you already have a Swagger API. You just want GraphQL. You have Swagger to GraphQL. You can automatically have a GraphQL API. It's not going to be a good GraphQL API, but it's going to be a GraphQL API. Let's say you're debugging. You can use an extension to view your GraphQL requests and responses in your browser, like this is a Chrome extension. Or let's say you want to generate documentation from your API. You can use GraphTalk. This is like GraphTalk. This is a static generator for GraphQL schemas, right? Or let's say you want a dynamic documentation. You want to be able to visually click through. That's GraphQL Voyager. You can use that too. Let's say you want to develop a GraphQL API. This is what GraphQL is. It's an IDE, right? This is from Facebook. It's one of the oldest ones. Super useful. Let's say you want a dark blue one of those same things with slightly different features. This is GraphQL Playground. It does a little bit more. That's basically graphical. Let's say you want a green one. This is Altair. It's a client like Postman, but for GraphQL. I've never used it or Postman, but it sounds maybe a little different. I don't know. Anyway, you could use it. Let's say you want JS Fiddle, but for GraphQL, you just want I have a server now. That's what Apollo Launchpad is. Let's say you use gRPC or Protobuf or anything like that. Your joiner is something Google wrote just for you, right? It just turns that into a GraphQL API. Let's say you don't want to deal with having a backend, or you just want to have your Postgres or whatever your database is. You want to turn it into an API. That's all you want to do, right? That's what Prisma is for. It does that. It also lets you define your API, your database schema with GraphQL for some reason. But anyway, let's say you're using Postgres specifically. It does what Prisma does, but for Postgres differently. I don't know. Anyway, you can use that too. Let's say you're actually using a graph database. Neo4j ships with a GraphQL extension. You can use GraphQL in your database. Let's say you don't want a backend at all. Just like, I'm just going to build the front end, someone else do that. That's what GraphQL is for. It's a backend as a service, GraphQL. Let's say you're like, okay, I would like that, but I want to use a startup. How about Amazon? Like, AWS AppSync is a GraphQL as a service backend. They have SDKs for iOS, Android, and JavaScript. It's based on Apollo. It just runs in their whole cloud infrastructure, right? Easy to sell to your CDO. Let's say you just want a content management system. This is GraphCMS, right? It just, it's a CMS. It's built with GraphQL. You can use GraphQL to build your UI, right? Let's say you don't like purple CMSs. This is, well, kind of purple as well, but it's another one, right? Like, there's so much of this stuff. I made these slides in February. There's a ton more now. There's a ton more, and we're going to learn about some more of them tonight that are going to be awesome, I'm sure. Okay, so where do we go from here, right? Like, I propose that in the same way that Clojure has really embraced React, we need to embrace GraphQL. So we need to embrace it, and we need to put a bit of a Clojure spin. Instead of reaching, so what can you do? Like, instead of reaching for REST when you go to build some UI, reach for GraphQL. It's not that difficult, and you will appreciate it after, I promise. Other things we could do, we could generate specs from GraphQL schemas. We could use these for, validating queries, mutations, subscriptions on the client side, and even on the server side as well. We could also use a proper Apollo 2 or Relay Modern wrapper. I've written Apollo 1 wrappers and Relay Classic wrappers in ClojureScript, but neither were that good and neither were open source. Anyway, if you want to work on this, let me know. Maybe we can collaborate. Eventually, and maybe we'll hear about something like this tonight, but we could use our own entirely ClojureScript client that doesn't depend on Apollo or anything like that, which would be cool, and I think we're going to hear about that. Anyway, essentially, GraphQL provides a much better experience than REST, and I really believe it's the way of the future, and that as a community, if we don't get ahead of it, we're going to be left behind. So my hope is that you will join me in making GraphQL as ubiquitous in Clojure as electric toilets are in Japan. Thank you.